Alright, today we're going to talk about graphing displacement from a velocity graph. So we've already done this where we plotted the graph based upon our kinematics equations, and we found all the points, and then we created our displacement graph after looking and plotting our velocity graph. Today we're going to talk about an easier way to do that if we are just looking at taking the area under the graph in order to solve. So how does that work? Alright, so here's a slightly more complex velocity graph. So we want to give you all the pieces to the puzzle when we watch the video, so we'll be able to solve all the things in class. So here are the key points. Alright, for every 10 seconds we're going to take the area inside the graph. So for our first increment here, we're going to take the area that is inside this little part of the graph. Well, how do we take the area? Since it's a triangle, it's going to be 1/2 base times height. So for us, if I go over 10 and up 60, so 10 times 60 times 1/2 is equal to 300. So that's saying that in the first 10 seconds, I will have a total displacement from my origin of 300 meters. So the area represents the displacement traveled during that time interval, right? So down here, if we're looking at this section, pretend we did the rest of those in between, and now we're looking at this time interval, what's happening now is that I have a negative velocity. Up here, when I have a negative slope, that doesn't mean that I'm going backwards. This just means that I'm slowing down. But over here, once I cross the 0 line, now I have a negative velocity, which means that I have turned it in reverse. So this negative area down here represents a return back to my origin. So if I do the same thing, 1/2 base times height, 10 times negative 40, because it's a negative value. So over here, I would get negative 200. So after I added up all these, if I wanted to find my position at this point, I would take 300, and then this area inside here was plus 550, and this area over here was just 200. So my area to this junction would have been 1050, and then I subtract 200 to know that I am 850 meters from my origin at that point. So the negative area just means that we subtract it from the last plotted position. And then we're good to go. Alright, let's see how this works in reality. Alright, so it's time to graph. Alright, so we already did the first one. So we said the area in here, 1/2 base times height, was 300. And it's a good idea to plot out all your areas first, so that way you make sure your graph is going to fit all of your data points. Now, for the second area, I do 2 little bars. Since this is just straight, it's just 5 times 60, which is 300. And then this area inside here is these 2 bars. Every little block, with a full block, is 100. So 250. Gives me an additional 550 meters after 2 seconds. So again, 3 seconds. Now I'm just looking at this triangle here. So that's a full block. 2 half blocks is 200. And now I have a negative area for this section down here. So 4 seconds, now I'm going back 200. So if we plot these over here, just to make sure, now the direction that your slope is going from each second also matters. So here, if I have a positive velocity slope, I'm going to want to have an exponential graph. So during that first second interval, I want to kind of draw a curve here to represent that I know that it's an exponential. I'm increasing my velocity. Now, for the next second, I have a flat velocity from 1 to 2 going up to another 300. So at 600, right in the middle here. So this is going to be a straight line there. And now I start to slow down a little bit as I reach 850. So 850 is here, and then I kind of slow down as I reach there. During the next 2 seconds, where I reach my maximum displacement of 1050, I continue to slow down. So I want to continue this slope here, and now at this point I'm going backwards, but I have negative acceleration. So at 4 seconds I wind up back at 850. So I want to keep that curved line going. So during this portion here, I have a straight line, and everything else is curved up or curved down to represent my displacement graph. All right, I hope that helps.